Good morning. Welcome to RubyKaigi Day 3. Can we get some applause? This is going to need to be an interactive session. This session is called RubyKaigi Committers and the World, and it's sponsored by Shopify, where I work. My name is Gemma. If we haven't met yet, I would love to meet you at some point. It's a very exciting session. We have all of the committers on stage right here in their blue t-shirts. And there are two main goals of this session. One is for the committers to be able to share their thoughts about the future of Ruby, Ruby 3.3, and specific things they're working on. And the other is to really allow for audience interaction. So please interact with us as much as you'd like. There will be some space at the end where we'll ask for audience questions. So if you have something you want to ask, start thinking about it now. To the committers, we don't have live Japanese to English translation, but if you need to speak in Japanese, please feel free to do so, and we have a few volunteers amongst you who will be live translators. So there are going to be 4 parts to this session. First, we're going to introduce the new Ruby committers, new since last RubyKaigi. We'll allow them to say a few words about themselves. Then we'll ask, some of the committers have pre-shared wishes for Ruby 3.3, and we'll ask them to elaborate on their wishes. Then we'll allow for some open discussion, and finally, audience questions. We'll take them, if you're in person, there's a microphone set up, and if you're virtual, please, you can write into the chat. Okay, so we have 2 new Ruby committers. The first, Matt, will you come introduce yourself, please? Yeah, we can.
Hello, everybody. My name's Matt. I work for Shopify in the Ruby on Rails infrastructure team. I've been working on CRuby for about nearly 3 years now. And I'm very proud to say that I'm now a committer. I look forward to working with you all. I'm going to be predominantly focused on garbage collection and memory management for the near future. Thank you.
Thank you, Matt. And next up, we have Make Now Just.
Okay. Hello, I'm Hiroya Fujinami, as known as Make Now Just as handle. I contributed regular expression matching optimization last year. Thank you.
Thank you. So for the next part, we'll go over wishes for Ruby 3.3, and these are grouped by category. So first up, we have wishes for YJIT. Maxime, can we ask you to start by talking about your wishes?
Sure. I think much of the strength of the Ruby programming language is in method calls, is in the variety of ways in which you can call a method with different kinds of arguments and with blocks, et cetera, et cetera. It's what makes the language so user-friendly. But there's also a lot of complexity underlying all of this user-friendliness. And so far, it's made it difficult to improve the performance. But I think we should be able to do more with YJIT to make Ruby calls perform faster. And that might unlock some very significant performance boosts. That's my wish for Ruby 3.3.
Thanks so much. If any of the committers have things they want to respond, please raise your hand or just indicate to me, and feel free to respond in this session as well. Aaron, yeah.
I disagree. I think Ruby should go slower.
Controversial opinion right off the bat. Kokabun, do you mind sharing as well?
Sure. The YJIT design is pretty great for optimizing the compilation speed but at the same time, because we try hard to not to make it the compilation so complicated and like slower, we sometimes don't often experiment with some optimization that takes some like optimization, like compilation time to do the very complicated optimization. So I guess we should like have opportunities to, or try to spend some time experimenting with like more like complicated optimizations so that we will not miss anything we should actually be doing for optimizing the Wells bench, for example. And if you compare the performance of CRuby and DraftRuby, we still have some rooms to optimize the YJIT for production workloads. So I'm very looking forward to making it much faster than the current stage. And for doing so, I think we shouldn't like stop doing the experiments. And then part of the reason why I made the RJIT is for doing that kind of experiments. So if you are interested in that, please come to my talk today, and I will explain how you could do that as well. And one more thing. One of the things I want to try is method inlining. And unlike DraftRuby, the difficulty in CRuby is that you make a lot of C codes in the generated code, C function codes. And if you do the C function code, that could also call method another method, and which complicates the optimization a lot because you have to almost give up everything when you make a C code, which doesn't happen for JRuby or DraftRuby because that's mostly not using the native stuff. So for making that kind of things optimize, I think it's pretty important to have something that could allow you to lazily optimize or de-optimize something inside the C function code, which I want to ask Alan to explain how we could lazily push the frame inside the C function, which he's been designing. And I'm pretty excited to have that capability because after that we could do something like method inlining and like not de-optimize something when we have the C function code. So I kind of want you to kind of briefly touch that topic.
So, okay. So,
You got put on the spot. I saw it.
yeah, I touched on this a little bit in my talk from last year too. But the general idea is there's a certain amount of data that you know before you go into any method just by knowing the identity of the method, like knowing who you're calling. And the idea is to move much of that stuff away from the instruction stream and into the data stream. That way, you know, it's a classic JIT move to spend more memory for speed. But that's the general idea, is to bundle all of that already known stuff up and then move it to the side of the stream. And we sort of already know that stuff from JITland because with YJIT analysis, we already sort of always know who we're calling when we're handling method calls. Anyways, it's very early stages. We'll hack together something, prototype, iterate on it. I guess see you Christmas 2023. Yeah.
Yeah,
Thank you.
Kokun-san, the optimization may take time. So that since JIT compiler is the runtime compilation, so that if we do the extensive optimization, so that we need more time. So that some JIT compiler, like a JavaScript JIT compiler, like a multi-level JIT compiler, like they run the simple non-optimized JIT compiler for the most of the cases, and if some methods are called extensively, so that they take the more optimized JIT compiler. So but you say that we are going to do more optimization for the YJIT compiler. So that do you mean that you are going to introduce some kind of the multi-level JIT compilation or something like that?
So I guess we could have some options to kind of tune how you want to optimize that. If you want to keep sometimes keep the compilation speed short as possible, and if you want to, if you have some time to warm up the application, then you could turn on that kind of options to, for example, have that tier 2 JIT. But for this topic, I guess it's interesting to ask Maxima about it, because she's pretty much against making the compilation slower, and oftentimes she's arguing we shouldn't actually complicate the compiler. So I'd like to kind of hear your opinion.
Sure. I mean, I think it's definitely possible to have a multi-tier JIT. So far, I have wanted to keep the architecture of the compiler as simple as possible, just because I think that CRuby is already very complex. YJIT is also very complex, and given the size of our team, I feel like there's a limit to the complexity that we can manage. But it is definitely possible to have a multi-tier compiler. I think if we did that, it might push us closer to an architecture that's more similar to what Truffle Ruby is doing. To be honest, though, I think maybe method-based JITs are a more natural approach to have a multi-level JIT. But if we went that route, it would push us towards something where we have background compilation threads and a compilation queue and things like on-stack replacement, etc., which would mirror the design of Truffle Ruby probably more closely, I think.
Yeah, I was actually. Is it working? Yeah. No. I was actually discussing this a bit with you yesterday, and yeah, I think the problem with the tier 2 JIT is lazy basic block versioning in YJIT currently is very simple and nice. But then if you go kind of tier 2 and you want to do inlining and so on, kind of explode the complexity very quickly, and the effort to also write all this, right? So it's a very big step. So that's yeah, that's gonna be a tricky one. Let's see.
But I also want Ruby to be as fast as possible. So it might be probably inevitable in some cases. So yeah, kind of looking forward to seeing that result.
I think because basic block versioning is sort of a newer architecture, we're I think the only production JIT using it. I think when it comes to tiering, if we study the problem carefully, maybe we can come up with something new in the space. That's probably different from what traditional tiering would look like. I feel like if we study it more, maybe we can come up with something that fits better, and yeah, the problem deserves more attention, maybe. Yeah. That's it.
Thanks. Anyone else about YJIT? I want to follow up too. We're going to talk later about other Ruby implementations, and so have more of a chance to talk about other potential lessons from Truffle or other implementations. Okay, so the next topic is garbage collection. And we have a few folks who have submitted bullet points here. Peter, would you like to start?
Yeah, so I talked about a smarter self-tuning GC that adapts to different workloads. So one of the problems we have at Shopify is that the GC causes very high latency at the very extremes, like P99, P99.9 response times. And a lot of that is caused by the generational garbage collector, which was introduced in Ruby 2 point something. It separates old objects, which are basically immortal objects, from young objects, which are newly created objects. If you think about your typical Rails application, you have a lot of long-lived objects that are, for example, the classes that are inside of your Rails app, and you have a lot of young objects that is created during the requests. Ideally, we never do a major GC, which is where we scan all of the objects and try to reclaim all of the dead objects, and we only do what's called minor GCs, which only scan the young objects. One of the problems with Ruby so far is that all of the benchmarks are toy applications, even things like Rails Bench. It's a single model, single controller. And so we don't have a lot of old objects. And so the performance penalty of a major GC is fairly minor on those kinds of benchmarks, whereas on a production Rails app, like the ones we have at Shopify, a major GC is a very high penalty. It runs in several seconds. And so ideally, we never want to run major GCs, or we want to limit the amount of major GCs to as little as possible. And so by doing benchmarks in production on a high-traffic Ruby Rails app, we can gain so much knowledge about how production Rails apps work and how we can optimize Ruby's GC to be smarter and more adaptable to extremely large applications that you cannot find in benchmarks. We've really only just gotten started on this work. My colleague Jean Boussier and I have worked a lot on tuning the Shopify monolith, and which is the world's largest Ruby app, and Storefront Renderer, which is our highest traffic app. And we found a lot of optimizations that would benefit large-scale Ruby apps. And again, we've only gotten started, and I think we'll be able to ship so many exciting new features in Ruby 3.3, where all of the large Ruby Rails apps will be able to see a huge benefit in P99, P99.9 response times.
Thanks, Peter. Next up, we have Samuel.
Here you go.
Ohio.
Ohio.
So one of the biggest challenges with scalability in Ruby is creating many threads or many fibers. And in a single process, when you create many threads or many fibers, you have many stacks, many system stacks for the execution of those threads or fibers. When you run the garbage collection will scan every single stack. And this creates a performance issue when the number of stacks is large. There should be some way to improve this. If we know that a fiber or a thread has not been active between the last GC and the current GC, we should not need to scan the stack again because the memory allocations or the references have not changed. So I would like to investigate whether we can improve the garbage collection. To give you an example of the kind of performance, if you create maybe 100,000 threads or fibers, the garbage collection can take maybe 500 milliseconds. So it becomes very, very slow. So this is a big impediment to scalable Ruby, and I have got a student on Google Summer of Code, Joyce Chen, and we're going to work together on this problem and see if we can make some improvements. Thank you.
Next up, we have Jean.
Hello. So it's kind of a bit like what Peter talked about, but I just need to rewind back. I know there's a lot of work being done on like fibers, many interactors, but for the foreseeable future, I think most applications will continue to pre-fork. Even servers like Puma that use threads or Falcon that use fibers, they still pre-fork because there's a limit of concurrency you can have because of the GVL. So a big complaint about Ruby that I hear often is its memory usage. And a good way to reduce memory usage when you use fork is to be copy on write friendly, which means any memory that was initialized before the fork and isn't touched afterward, like it can be read but not written, it will be magically shared by the operating system, which can very drastically reduce the memory usage of your process pool. And so my wish for Ruby 3.3 and later is to really refactor some parts of the VM, especially the garbage collector, to avoid writing to existing region when it can. So this includes, like, for example, Peter was talking about major GC. The vast majority of your objects are created on boot and just stay there forever, like, say, classes or things like that. And if for some reason in one page of Ruby objects, there's one object you can garbage collect, but all the others are just immutable, never changed, it's actually harmful to free that slot. It would be better to just abandon that slot and leave the page unchanged, and that would be basically free memory. So yeah, that's the kind of things I hope to introduce in MRI in the future.
Thanks. Next up, Koichi.
Good morning. Before talking about the Lactal local GC, I want to emphasize that. So last year, we held this session, but this year the Shopify is provided this session. But so please do not understand that. So Cookpad stops the contribution to the Ruby development. We continue to the Ruby development and other open source software contribution. So anyway, so I think this is very great to have an English session, and we do not have any irregular speech from the committer, so it was very clean discussion. So anyway, so about the Lactal local GC. So Samuel said that to make a scalability, to make more scalability, we need to care about the stack garbage collection, and of course it is absolutely true. So this is Lactal local GC is another answer to provide more scalability. So currently Lactal system doesn't have enough performance because of the garbage collection, because we need to stop all of the Lactal to make a consistent garbage collection. Better making the Lactal local GC, we can do the garbage collection per Lactal. So it means that we can provide a parallel garbage collection. So because the Lactals can run in parallel. So to make a more and more performance, this model is best, I believe. So I want to. So this session subtitle is Ruby 3.3, but I'm not sure we can make enough implementation to the Ruby 3.3. But I think so. This year or next year we can show some achievement about that. Thank you.
How far we can see? How far we can see in the Ruby 3.3? I mean, the NM Raptor will come into the 3.3.
Yeah, I want to build. The goal is to make a MN scheduler to Ruby 3.3. But so changing this kind of data structure or the core logic, maybe we need to do more and more debugging. So I couldn't say this is enough quality. This has enough quality before the 3.3. So maybe so at least we can release it with optional one. And so I'm not sure it is a runtime option or a static option at the build time, but maybe something we can provide it. And so just now, so on the another concern is compatibility with other platforms. Just now I only tested on the Linux system, so Windows or Mac OS or some other operating system. We need to provide support. So I'm not sure when we can make such a full support for that. But so we continue to that.
Yeah, I'm expecting the NM scheduler because of with that kind of scheduler, we can open up the new possibility of the concurrent programming in Ruby.
Any other thoughts on garbage collection or responses? Okay, so next up we have parsing, Kaneko.
これは英語で言った方がいいのかな。
通訳する
まあ、頑張ります。Hi, I'm Kaneko. I'm an author of the Llama LR Parser generator. So one big news is yesterday I replaced CRuby's Python with my Llama LR Parser generator. So now there are no dependency from CRuby to the Python. So I really love the GNU Python and I respect the GNU Python. However, I can say Python is dead.
But it's dead.
Yeah. My plan for the next Ruby is solving these three big problems currently discussed with among the committer and the developers. So my plan is expanding and using the Llama LR Parser generator for the foundation to solve such a problem. However, I need a lot of feedbacks and help from you. So if you have any interest in the Ruby Parser or the Parser generator, please let me know. The good news is that Llama Parser generator is written by Ruby, pure Ruby. Though it may be easy compared with GNU Python to hack or debug the Parser generator itself. Yep, thank you.
Any other thoughts on parsing?
Gemma, do you have any word from the YAP side?
I do have thoughts on parsing. So Kevin Newton has been leading a project that I have been working on as well about YARP. He gave a talk about it earlier in the conference. So we are rewriting a Ruby parser using recursive descent parsing on the YARP project. And our wish is that that will ship with Ruby 3.3 and with Truffle Ruby and JRuby and quite a few other Ruby implementations. Kevin Newton just had a baby, so he is at home taking care of his baby. That is, otherwise he would be with us today.
So that made me force me to make a hard decision.
So I guess 3.3 is going to have 2 parsers, but is 3.4 also going to have 2 parsers, or are we going to have just one in the future? What do you think, Matt?
At least 3.3 will come with 2 parsers. One is the with the Kaneko-san, replacing the existing the parse Y, and the YAP come with YAP will be migrate from the Shopify organization to the Ruby organization, and it will be bundled, and that we modified the interpreter to add some kind of the command line option to switch the parser. But that's as far as I can promise. But after 3.3 released, I will suffer from the making the hard decision. And I hope 3.4 will be shipped with the one single universal parser.
Yeah.
Yes. So does this mean that will we have a Ruby API to YARP when we merge it in? Will we? So you said maybe we'll have a command line tool to switch out the parser, or command line flag that we use to switch the parser out. But is it okay if we also add a Ruby API for YARP as well?
Yes. Yes. If the one case is we leave the BNF parser for the future, even if we choose the BNF parser for the future, so that we have to provide the YARP API anyway.
Okay.
to provide the universal parser for the truthful Ruby, JRuby, and other the parsing tools like the Ruby LSP or something, anything like that.
Okay, that's why I was asking. I just wanted to make sure that was clear. Okay.
I agree that API-wise, the YAP is far better right now. And the SD structure is different, but it is much useful for other implementation like truthful Ruby. And I agree with that. So even if we keep the BNF parser, so the same API should be provided.
Right, I guess you know already, but like YAP already has a way to get the AST as Ruby nodes. And so, yeah, I guess it will also be a gem, so we could already have it anyway. But I think it just makes sense to also have it as a default gem to already have it, or bundle gem in CRuby in 3.3 then, because then it's just convenient and like it shows like, okay, now the parser tool can really rely on like a trustable parser that parse the same way as CRuby would, and it's easy to use and so on. It's also fast because so far we had the parser gem, but that was unfortunately very slow. So this will finally fix that.
Yeah,
it'd be great.
Yeah, agreed. When we move it over to the Ruby namespace and mirror it back, I think we can definitely expose that API that already exists. Mats, you got one more question. It was mumbled from behind you. Is it going to be Ruby 3.4 or Ruby 4.0? Some other committers, I overheard them ask.
I have no plan about the Ruby. No concrete plan for the Ruby 4 yet. So don't ask me about the concrete idea. But I have a lot of crazy ideas. One of them is the forking the Ruby 4 and will be the testbed for the multiple leadership like after I retired from the community. Then the committee the work discussed together to make the Ruby 4 as the play with the Ruby 4, and the Ruby 3 will keep being Ruby, being the canonical Ruby, and maybe we will import some ideas implemented in Ruby 4 into the Ruby 3 or something like that. But it will be very interesting idea because in the Ruby community, most committers, including most core members, including committers, do not want to beat me and replace me. If you do, raise your hand. And so that I think we need to practice about the leading the community and the language design. So that unfortunately I'm immortal. So how would I anyway? So that probably keeping the 100-year language, 30 years language, we have to be prepared for the future. So the making some kind of the test bed for the practice material as Ruby 4 as a practice material might be some kind of the good idea or maybe crazy idea.
Aaron, did you have something?
I have two ideas for Ruby 4.
Mm-hmm.
The first one is we should do Ruby 4x4.
I was going to make this joke. I was going to make this joke.
My second idea is, I guess, not really my idea, but we should do Ruby++.
I propose Objective Ruby.
Yeah, the 4x4 is a very powerful vehicle.
4x4 is pretty powerful. And last year or 2 years ago, I gave some kind of presentation about the Ruby 3x3 Redux, making some future Ruby 3 will be 3 times faster than Ruby 3.0. And yesterday, the Maxim's in Maxim's presentation, we are pretty close to that. Yeah.
Nice. Okay. Any other discussion here? No. So next up, we have types, Samuel, again.
So Koichi introduced shareable object. And I think the semantics is useful, but maybe not universally understood as a concept. And I would like to look at whether we can introduce support for immutability at the Ruby level, so we can create objects that are immutable. It's like deep frozen objects, but maybe with language support and object support. So there was a proposal for it. It's had some discussion, but it hasn't gone any further. Matt, do you have any thoughts?
Good.
About immutability?
I basically agree with the introducing more immutability to the language, but we are lacking about the notation because of the for example, in the past we put the string freeze everywhere to the Rails repository, and that's good for the maintainability and the error proneness, but at the same time it's ugly. So if we could come up with some kind of the good notation about the marking this object is immutable or something like that, but that would be nice to have in the language.
Yeah.
But currently I have no idea. Some kind of the syntax mark to the noting this object is immutable or something.
Yeah. So the notation is important.
Yeah. Notification. Yeah.
One other problem we ran into was that Koichi, you stole the last remaining object flag for shareable. So it's very difficult because we have a fixed number of flags on the objects. Do you think we should prefer shareability or immutability? Do you have any thoughts?
So just now I don't have a good answer about that. Maybe so I think so immutability. So some languages like Rlang or some function language provides more and more immutability. So I'm not sure. So for implementation, we can modify something better. So for the language, so we should introduce more and more immutability because so maybe Ruby programmer love such a mutating object-oriented programming. So maybe it is not a direct answer to your question, but maybe so. Another answer from another aspect is so with the Lacta system, so we need to make immutable object to communicate with each other. So for local system, so in Lacta we can enjoy modifying mutable state programming. So we do just now, and to make a more and more bigger application with multi-Lacta, so from this perspective, it will be a immutable object. So I think this kind of low layer or the mutable layer and immutable layer is one approach to make some robust application, I think.
Yeah, awesome. Thank you.
Yeah, the newly introduced data class is the part of the solution, but not full solution.
I just wanted to touch quickly on the object flags. I'm currently got a PR in progress to move the age out into a separate bit mask for some of the MMTK work. We're still going to need to use one of those 2 bits to annotate whether or not we need to trigger the right barrier, but hopefully there should be one more freed up soon.
Just for the audience to understand, these bits on objects are very coveted space, these flags. Okay. Next up, threading. Jean, you have a point here?
Yeah, it's a bit of a late addition. I mean, it was in my head for a while, but I thought about it again when I saw Ivo's talk yesterday on the GVL. So for those who don't know, since a single thread can execute Ruby code at the time, there's this constant defined in the source code, which is after a thread run Ruby code for 100 milliseconds, it's scheduled out, interrupted for other threads to potentially run. And I've looked at the source code several times, and there's this comment, I think by Koichi, that say 10 milliseconds is too little, but 100 milliseconds sounds good. But I'm not sure a single value can actually be best, so I'm really wondering, I haven't tried implementing it, but I think it's doable, to just assign on, like configure each thread and say this thread have this quorum, and we'll switch after, so that if you have, say, an unimportant background thread that can just run when others are doing IOs, you can set it to a fairly little values, and if it's an important thread that impacts your latency, you can put it higher. So yeah, I need to talk with Koichi about it.
I completely agree about that. So this current approach, current strategy of thread switching is implemented in maybe 15 years ago, maybe. So we need to change on the modern computing situation. But so just now I'm making MN scheduler. So it's so just now I use same strategy, but there is many room to improve that. So discuss later.
Just a reminder to committers also, if you're not speaking because of the translation, again, reminder, feel free to speak Japanese as well. Next up, Jeremy. Fewer bugs. I seem to remember this comment.
Of course.
Have you made it before this one?
So this is hopefully uncontroversial, but it's in between, let's say, last year and this year, the number of open bugs in the bug tracker has increased slightly, mostly because I have not been doing as good a job triaging a gomenasai. So I don't think I'll have that much time this year due to various things, but hopefully next year I can get much more into bug tracking. I think I spoke with a couple other people at the conference about increasing the number of bug triagers. So if that is something that you are interested in, I would love to hear from you so we can increase the number of people looking at bugs and trying to work on fixing bugs. I think that would be great. So thank you very much.
Thank you. Other Ruby implementations, we talked about this a little bit. Benoit, if you want to add.
Okay. Yes, I wanted to talk about a bit of the relationship here between TruffleRuby and CRuby, and also like in terms of research ID and optimization. And like what I noticed over the years, like there was a lot of optimization that were added to TruffleRuby and eventually made their way into CRuby. And there's two things I want to note there. Is like first of all, like these optimizations were not necessarily invented by TruffleRuby. They might exist in another language, but I think they were first introduced in TruffleRuby. And also, in most cases, probably it wasn't like copied from TruffleRuby or something. It just happened in CRuby too at some point. So it's kind of interesting to see all this kind of optimization pass from one implementation to another. And so I have a few examples. Like, for instance, like in 2021, TruffleRuby introduced like a just-in-time compiler for regular expression. And one of the main features is it can do linear time matching. So you can match a regex in linear time, so in time proportional to the size of the string. And then CRuby, like, that was kind of a too much effort, but they actually did something similar, where like they actually reused the backtracking implementation, but used some new academic paper that came out to kind of achieve a similar property. Yeah, sorry, I kind of need my slide. Yeah, otherwise, like another one is we have like, for instance, is or kind of, to have an instance of check. That's something that's actually like we did in TruffleRuby based on what Java did for instance of. But then John Houghton from GitHub later found out by himself, like, okay, a way to do it in Ruby, which in the end was kind of the same, basically. So that's a cool anecdote, I think, like just like this kind of thing we just find out with enough time looking at Ruby and how to optimize it. Then there is shapes, which are in TruffleRuby since a long time, and then in CRuby since now, I think, a year or two. That's also pretty important for implementation. And then, yeah, one thing I did directly in CRuby, I did it first in TruffleRuby, like I was looking like when we do instance eval, and there's a def, a method definition inside it, it actually gets defined on the instance itself. So it gets defined actually on the singleton class of the instance. But it means that every time we do instance eval, we have to create a singleton class, and creating a class is very expensive. And so when I did this in Ruby, I was like, I don't want to create a class eagerly, like that feels wrong. So I did it lazily. And then at some point later, like on some discussion on the Ruby tracker, we found out like, oh, but this seems like unfortunate, like instance eval is too slow and so on. And I just shared my ID, and then eventually like this made it this way as well in CRuby. We were like, okay, oh yeah, that's a nice way to do it. Let's implement it as well. Yeah, I think there's a couple more examples, like finer grain method and constant invalidation. I think it was like completely orthogonal effort, mostly by Koichi on the CRuby side. And in Ruby, we redesigned like 4 times how we do method invalidation, because there's so many trade-offs there. There's so many possibilities. And so it's always worth improving that and always be more precise, so that, for instance, when you just-in-time compile code, you don't throw away things that don't need to be. You throw away the least possible, only what's needed. And yeah, the one last thing, I think that was, also like we have tons of inline cache in Ruby, and I think that's more difficult to do in CRuby, but still, like over the years, CRuby gained more inline cache, so now they have one for super and response to and so on. I think part of that work is by Tenderlove. And yeah, I think that's about it. So I just wanted to give some example of some cool optimization that come into Ruby and kind of flow between Ruby implementation.
We just take the good stuff.
Yeah, and of course, like I think in Ruby there's quite a lot more optimization. Some of them are like harder to apply to CRuby, or like they have less effect because maybe you need like, I don't know, inlining to have a bigger effect there. But still, like usually when there's something fundamental like this, it tends to apply globally in some way. It tends to improve Ruby implementation in some way, no matter which implementation it is. Thank you.
Yeah. It's interesting, too, what you're saying echoes what Kokobun was saying earlier about argit's use in CRuby. OK. Benoit again about...
Twice in a row. Yeah, we also had a discussion, we can match it together. So I was talking at the beginning about like matching a regular expression in linear time. And I think this is quite important because I think in the last 3 years, there's been about a dozen REDOS, so that's regular expression denial of service. So it's about like the most common denial of service issue for Ruby, and not only Ruby, or actually many other languages. And it's kind of becoming really important to solve this, because now whenever somebody writes a regex, I don't know, to validate an email, there's a very high chance that if it's a backtracking regex engine, it can go into exponential time and so on. And then like just a user querying, like using a website can actually make it crash or make it unusable for the user, which is what nobody wants. And so they're like, so Ruby introduced something that did the linear matching using like a kind of some theory from a old time ago, but it was the first time to apply it to Ruby, because Ruby regular expressions are very powerful. They're a bit like Perl, and Perl like the most complex regular expression that exists. And so yeah, we applied to that, and we can't apply it to all regular expression, right? Because some of them are just too powerful. So you can have nested group somehow that reference itself. I mean, like you have some really complicated things and kind of conditionals matching and so on. There's some construct that just cannot be optimized that way, cannot match in linear time. And so the real question is like, how can we avoid REDOS in the future, right? How can we avoid this problem and eliminate it once and for all? And that's kind of an open question, because like for the regular expression that are already linear, then it's fine, it already works, it's fine, there's no problem there. But there's some expressions that are not. And then we need to make kind of users aware of that. Like we can't just not support them or throw an error anymore for those that are not linear, because that would not be compatible enough, right? So we need some kind of nicer way to migrate. And yes, I want to come to CRuby. So CRuby, they didn't implement like a finite automata method for the linear matching. But they used this academic paper, which is fairly recent from, I think, from the security community. But they realized, like, actually we can have the same properties, and this was done by Make Not Just. We can have the same property as this kind of DFA linear matching with a backtracking implementation by just noticing that if we come back to the same state and the same place in the regex, so the same place in the regex and the same position in the string, then actually, okay, we are searching too far. We're probably backtracking too much. And at that point, actually, we don't need to backtrack anymore. We can just save the result that we already backtracked and it's not going to match. And this, similarly, doesn't work for all regex, but it works for many. And so these two approaches in the end are very similar for the user. Like many regex are linear and they are fine and we don't need to worry about redos, but then what about the rest? And I think the biggest problem for the rest is like whenever there's a redos, people typically fix it with an atomic group, which is a way to say I don't want to backtrack in a specific place in a regex, but that's actually not linear always, right? Atomic group by definition can only be supported by a backtracking implementation. So there we have really like a problem, a dilemma, because you're like either the regex is linear, and then it's on Ruby 3.2, on Ruby 3.2 and more, or on Truffle Ruby, it's fine and safe. Or it uses atomic group, and then it's not linear, but then it's potentially maybe safe on older version, right? So I think at some point, like maybe when Ruby 3.1 and older are not used anymore, we can maybe just make more regular expressions, just rely on this linear guarantee that we can check. And we could, for instance, maybe warn. So now we actually have performance warning by Jean recently, where we can warn, say, okay, this regex is slow, you should rewrite it, or you should like avoid these crazy powerful features that actually make it dangerous because they can run into redos. So I think that's a way forward. And I think another way, and that's kind of really like, I think an interesting question is like, could we ignore atomic group? Could we treat atomic group as just regular group? And I think to some extent it works, because often like this atomic group was just added to kind of avoid too much backtracking. But then if we have a linear regex to start with, it wouldn't be a problem. We wouldn't have this backtracking. So if atomic group are used only for performance, then it should be fine to ignore them. But sometimes they might be used for semantics. They can be used to express things in a different way. And then it's not correct to just treat it as a normal group. So yeah, I hope we can eliminate redos. We still need to think how to do it. I think we can find out something like give a warning, because that's easy to do, and it will be helpful for user to know, okay, which regex need attention, need to be changed or improved, or need to be double-checked that they're actually correct, and so on. Thank you.
Okay, thanks very much. I completely agree that we should do more and all we can to make to try to eliminate as much as possible of this problem with maybe timeouts, with warnings, with improvements to the implementation, with getting the word out here that some regular expressions are very convenient and very helpful, but some might be dangerous and so on. But we should be aware that asking to eliminate all possibilities that it takes a long time is the same as asking, well, Ruby should avoid infinite loops. Yeah? Please put the facility into Ruby that we won't have infinite loops. If there's an infinite loop in the program, it tells the programmer, yeah? And we know that that's impossible. So we have to be careful that we understand that there's something that are possible and something that are not. Thank you.
Right. I think luckily, like, yeah, infinite loop is like the halting problem, no chance. But for regular expression, we already have a way. We have regex.linearTime, I think, is the method in 3.2 or 3.3, and we can check if it's going to be linear. So we can just warn for the ones that are not linear. And of course, yes, it might be difficult to write them in a linear way. That's, I think, part of the challenge. And yes, we also want to stay compatible. So for instance, this performance warning is opt-in. It's only if people opt into it.
Yeah,
which is nice because
I expect Robocop to notify or validate the regular expression in the applications and to use the reject speed dot linear time and show warnings or something to change the regular expression also.
日本語でも
なんかロボコプのルールってすでにあるんですか？
わかんない。
あ、わかんない。
作れるよって話。
なるほど、はい。まあチェックいやなんか
いいよ、日本語で。
話すことないなって思ったんですけど。
これから拡張していきますとか、藤波さんの方でレギュラーする DFA ベースにする。
Do you want the microphone?
Okay. So, アトミックグループとか、拡張、アトミックグループは多分簡単にリニアタイムにできるっていうのはできると、思います。
I think it is possible to make the atomic group to the linear matching.
はい。ただ、先読みとかはちょっと難しいかもしれない。今の実装のままだと難しいかもしれなくて、ちょっと方針変えないといけないなと思っていて、どうするか考えているところ。
With the current implementation, look forward might be hard to implement how to implement the linear matching, but I'm thinking about changing the implementation for the future.
そうですか。バックトラックとかがあるときはやっぱ、理論的に難しいというか難しいところがあると思うけれど、ただ全てをリニアにするためになんかバックトラックとかを使うべきでないっていうことをなんか強く言うようにやるのは Ruby 的じゃないなっていうのは思っていて。
With the backtracking, it is theoretically impossible to make everything linear. But however, prohibiting the non-linear matching is not the Ruby way.
のでどうしていくかっていうのは課題の一つだと感じています。
Yeah, I still wonder for the future strategy for the making more regular expression more linear.
Thank you.
私の通訳に出してありがとうございます。Yeah.
So John and I are on the Rails and Rack security teams, and every time we get a security issue that's like redos, I'm just like, So I just want to say thank you for your work.
I forgot to say the good news, because I think so in CRuby it was only in 3.2, so it's fairly recent that they have linear matching. But in TruffleRuby, I think out of the last dozen readers, I think half of them just didn't apply to TruffleRuby because of the linear engine, regex engine. And so this is already solving kind of half the readers, and now we kind of want to solve the other half by making sure the source, we don't have non-linear regex anymore. Kind of, and yeah, we need to find a way for that. We need to find a proposal and agree on it.
Yes, I will more. I will learn more with regex engines. More, thank you.
And I know many other languages actively contribute developing the non-linear or DFA-based regex engine. For example, .NET, Microsoft.NET is also developing the DFA-based regex engine. So we should learn the other computer science results.
Thank you all. So we had one discussion point about this specifically, but we're just going to move right past it because I want to leave time for audience questions. So if you have a question, it can be in Japanese or in English. There's a microphone right in the middle there and one in the front here.
Gemma? Mic.
Oh, yeah.
Sorry, I forgot to add my topic in types section. I cannot speak English at all, but I'll give it a try. Yesterday, in my talk, I showed a demonstration of TypeRock, which is a type analyzer for Ruby that is I'm creating. In the demo, I showed type block now allows inline type annotation as a comment. Before my talk, I asked Matt how he feels, and he said, I'm not 100% satisfied, but it's okay. So I have one question to you, the audience, whether you like or dislike inline type annotations as a comment. So please raise your hand if you like type annotation inline type annotation as a comment, like as I showed yesterday. Please raise your hand. No.
Excuse me. Can we somehow show the code, the actual code, how it looks like? Can anyone?
I'm not ready, sorry.
Like, can anyone write on the chat, maybe? なんか実際のコードを見て喋りたい。そう。
いやでも難しい。
つなぐのが。
ソダさん書けない。
この PC に書ける。
You can come on my screen too if you want.
書いてくれた。
Do you want the desk? It's here also.
Yeah. 諦めて日本語で言うと、メソッドの、定義の上に、コロンハッシュ、ハッシュコロン and RBS が、書けます。はい、っていうのを、タイプロフでは許しています。これはオプショナルで書かなくても、書かない場合は、渡される可能性がある方を、推論して出すっていうふうにしてるんですけど、書いた場合はこれに制約されるというふうになってます。はい。翻訳。
Oh. So you could write that way, like you use that hash and a colon to add the type annotation. By the way, I have a question, but why don't you also support like yard, the document?
I don't. This is not place to discuss, so let's leave it. Okay. I want to ask a question to audience. So, 思ったより少ない人たちが、手を挙げてくれた気がしてます。
ごめん、もう一回手を挙げてもらってもいいですか。この文法で、コメントを入れるのに、賛成の人は手を挙げてもらってもいいですか。こんな感じ。If you prefer to add the type annotation comment to the programs, if 1/3, half, 50%, 0.
It's pretty hard to see. I think maybe a little.
Thank you. Lower your friends.
Yeah.
だって。わかりました。
Okay, thank you.
Yeah, no worries. We will still have time for maybe a few questions. So if you have a question, if you want to put it into the chat, if you're virtual or if you're here and you want to ask in person, please come to one of the microphones.
質問があればマイクのところまで、ここと後ろにありますので、あるいはチャットで質問してくれてもいいです。日本語でもいいです。いた。はい、お願いします。
Hello.
後ろは早かった。
Hi.
Yeah, Ufuk.
About the types thing, I just want to add a comment and I have a question afterwards. People already write their types in comments using yard annotations, but the problem with yard annotations is the type syntax is not expressive enough. to describe a lot of the complex types that you can express using RBS. So if people are already writing their types in comments, and if we already have a powerful syntax for types in RBS, we might as well just add it as a comment on top of our methods, is what I think. The question I have is Chris Seaton, who we tragically lost last year.
Yeah.
His last conference talk was about the core library of Ruby and how if we can re-implement that in Ruby instead of C, it will allow the JITs to make performance better because you stay inside of Ruby more of the time instead of going into C and then going back to Ruby. And he was also saying that it would allow people to contribute to Ruby more effectively because then they would be writing Ruby instead of C. So what do you think about that kind of a future?
誰が答えるべきかな。With more type information, we can do more optimization. I know, for example, the JIT compiler can optimize the, or can remove the type guard if we can provide, if we can obtain the type information of the argument and the return type. But at the same time, the similar thing can be achieved by the the runtime type information.
Yeah, I guess I would add there's a trade-off with these kinds of things, right? I think it's not wise to be an absolutist when it comes to these things. Like one of the things that people hate about Java is like this insistence that like every function has to be a method, right? So like, sometimes you just want to have a function that's not attached to a class. I think there's some room for rewriting some of the runtime in Ruby, but at this point, I think YJIT is not mature enough for that to be viable because it would add to compilation time, and sometimes we would be reducing the performance in some cases. That being said, like we have looked, Kokubun has prototyped, rewriting .each loops in Ruby, and we found that in some cases we did get better performance. So I think probably like an incremental approach. But if we wanted to rewrite all of the runtime in Ruby, then we would also need some way to cache the generated code so that the startup could still be really fast.
So yeah, I actually tried implementing array each in Ruby, and it contributes to reducing the overhead by crossing Ruby, C, Ruby, like array each is currently written in C, so like if you need to cross the C boundary, you have to invoke under virtual machine for every single iteration, so it has an overhead and like, but at the same time, as Maxime said, YJIT is not still like sophisticated enough to make the Ruby code as fast as C function. So like, I think we are still not ready for making everything written in Ruby, but for things that are like things that matters, I think we could try doing that. And also, if the data with the benchmark support, we should be able to do that. And also, another problem is that when we rewrite things in Ruby, like for example, array each, Benoit complained that, oh, that's not thread safe, so like that's kind of like another problem. Yeah.
Yeah, like for some core methods, it's very difficult to define them in Ruby because like you're defining Ruby with Ruby, and you're like at some point you cannot leave it something that's not written in Ruby, or you would need a bootstrap virtual machine or something, which is not really convenient. But on the other hand, I think a large part of the core library can be written in Ruby, and so that's the case. For instance, it was the case in Ruby News, and it is the case in Truffle Ruby, and also to some degree in JRuby. And also I track the history of every Ruby version, and every Ruby version, even in CRuby, there are more methods defined in Ruby. So there's a progress towards that. It's not super fast, but it's going in that direction. And I think kind of many advantages, like Ufuk mentioned, like it's more easy for people to contribute to, and we have seen this for Truffle Ruby. So for instance, when we update to a new version, we update to say 3.2, we actually have contribution from many different people, because it's very easy to write Ruby code. So if there is a new core method, that usually just write it in Ruby if it's possible, and then that's it. And then kind of any Rubyist can do that versus someone that knows virtual machine well or something, or C well, or CRuby well, and so on. Yeah, so I mean, like, I think if there was more methods written in Ruby.
Next question. Yeah.
I'm sorry.
Yeah, their time is running out.
Yes, if you're more in Ruby, it's great because you can share more.
So unfortunately, we are down to the last few seconds of this session. Do we have time for one more comment? It's okay or no? One more comment? Yes, okay.
Yep.
One more comment, Naruse-san?
From audience.
From the audience, one more question?
Any audience question? No?
It was the same question?
Same question?
Oh, we got very lucky.
From my answer is the foreseeable future, we are not going to integrate the static types, or even in the inferred one, and explicit one into the compiler. That's my answer for the foreseeable future.
Okay, and with that, we will conclude the session. Thank you so much again to the committers for being on stage and for answering the questions, and to the audience for being here and a part of it as well.
Anyway, I released the Ruby 3.3 preview 1 yesterday, so please check it and try it.
Let me say one thing. One sec. Time to take photos of the communities. Come on.
Committers on stage.
写真撮っていいよ。
そういうこと。カメラいっぱいあんな。
もういいかな?
So I would like to add one announcement regarding the after party tonight. You need to visit the stores booth located next to the reception before leaving this venue by 4 p.m. So please make sure you have checked in with stores team to attend the after party. アフターパーティーも受付がストアーズさんのブースで必要なんで、まだ来てない人は結構いるらしいから来てくださいとのことでした。お願いします。